Hello guys, welcome back to my channel Memo African Motives, still working on engineering science and 3. So in this platform we are going to continue still working on friction, still having question papers that we are going to focus much on as we prepare ourselves for the exams which are ahead of time. So what we have in this case is a question from one of the question papers that we are having, which is on friction. So that is what you're going to be at least focusing on. So guys, if you're new, you can consider subscribing so that you won't miss any of the classes that we shall be having from Memo African Motives. So let us quickly rush through the questions that we are given. The first part is to explain the term angle of friction. Okay, so that is on 4.1 and we've got 2 marks for that. Okay, so we can explain this as the angle of friction, that it is that angle between the resultant force and the normal reaction force. So that is the angle that you find between the resultant force and the normal reaction force. So that was it worth for 2 marks, guys. And another part on 4.2 is that a horizontal force of 500 Newton, take note we are given a horizontal force, is required to move an object with mass 10 kgs across a horizontal surface at a constant speed. Calculate the coefficient of friction. All right, so we are just given one force here, guys, which is a horizontal force. Okay, so you're given the horizontal force, which is 500 newtons in this case. Then we are given the mass of the object, which is the mass of the object, which is 100 kgs across the horizontal. Okay, so we are given a mass of 100 kgs. So from this information we are supposed to calculate the coefficient of friction. That is the coefficient of what? Of friction. And we can agree that the coefficient of friction is actually equivalent to the frictional force over the weight or the normal force that you are going to have, which is actually the one that opposes the weight. So the frictional force, because it's moving on a horizontal, maybe it is going this direction. This is the horizontal force, which is 500 newtons like this. Definitely there is going to be a force which opposes here, which is the frictional force. So as you can see, it's going to be equivalent because of the direction. This one is going this way and this one is going this way, so it's going to be same. But according to the object that we have, we are going to have the weight component, which is the same as the normal reaction that we are going to have, which is equivalent to mg. Remember guys, from this concept, that this part is on a horizontal surface, so this side is going to be equal to this side is going to be equal to this side, but only opposite in values in terms of the signs, but same magnitude, so which means these are the same values. All right, so if that be the case, therefore we have to calculate, because already the frictional force we said is equal to Fx, which is this 500, so we need the weight, which is equivalent to N, that is from the weight we've got mg, which is 100 by 9.8. so if you multiply these guys, you're going to obtain 908. so this is what you're going to have as the weight there, which is just mg as in newtons there. So which means we can actually substitute here to find the coefficient of friction, which is a 500 over 980, or you can just use 100 times 9.8. It's still one and the same thing. So if you are to divide, you're going to obtain 0.510204, something like that, guys. Okay, so rounding off, this can give us 0.510 as the coefficient of friction. So you can just leave it like this, or you can write it as 0.51. Still, it's one and the same thing. So that is what we are having there as the coefficient of friction. So the most part that I want us to see is this part. If you are to cross-check from the classes that we had, we worked on a typical question like this, where we ended up drawing a diagram like this. but this time we are given a drawn diagram. So are you seeing that is the same thing just like what we had? So in this case here we are given okay, this angle of 20 is for this part here, that is where we have this 20 degrees on this part. So given that the fig 3 shows a body with a mass of 50 kgs, okay, so which means this body has got a mass of 50 kgs here. This is the mass that we are having on an inclined plane making an angle of 20 degrees with the horizontal. All right, calculate the magnitude of force F required to push the object up the incline at a constant velocity if the coefficient of friction is 0.4. Okay, remember the concept that we did last time, guys, where we had to what can I say, taking this information into a simplest diagram that can actually give the exact thing that we need here. Like if you were to cross check, we are given that this is like the body that we actually had previously, and there we're given something like this because it's going to be pushed this way, so that is going to go up the incline. So this object is supposed to go up the incline, so definitely there is going to be a force that is going to oppose, which is the frictional force. So there you're pulling or you're applying a certain force to go upwards. Then here we are given a certain force now which is also pushing this to go upwards. So this is going upwards, then you're opposing to make, so it's like you're taking this upward, then the frictional force is opposing because it's supposed to go upwards. All right, so remember guys what I told you, that in order for you, because here the question is to calculate the magnitude of F required to push the object up, it's going up the incline at a constant velocity if the coefficient of friction is 0.4. So we're given the coefficient of friction, which is not much important for now. We're going to talk about this because that is where we are going to obtain our answer there. So we said, because we know that the coefficient of friction, just like what we did from the previous formula, we saw that it was actually the frictional force over the normal force. The normal force that we can have in this case, that in this case we used it as the weight because it was equivalent to the weight. But in this case, we're going to use the normal force that we know. So it's frictional force over the normal force. So the frictional force is going to be taken from these parallel components, because as you can see, it's actually parallel to the surface, that is to the plane. So this is what is going to happen here. You are going to have the one that is perpendicular and the one that is parallel in this direction. So according to this triangle, guys, as you can see, it's a right angle triangle that you're going to formulate here. So this is opposite. Anything that has to do with opposite, guys, from your sign, know that, guys, from your soccer tour there, okay, something like this. So you actually know that whenever there is to do with opposite, because it's either, let's not talk about tan, because it's either you have got sine or cos, horizontal, vertical. So the moment you are given where there is an opposite, you know that it's sine, because cos cannot have this opposite because there's adjacent. So this is going to be sine. So this is going to be F sine 20 degrees, and this is going to be F cos 30 degrees, which is this part here, not the frictional force, no, this part that is going this direction. So for you to equate these now, or for you to formulate equations, you must also have the parallel part, which is taken from the same object. So you're going to reflect this to the object, direct to the object like this. So it's going to be like this. So this is how it's going to look like, just like this, guys. All right, something like this. So this is going down and this is going this direction here. Now this is your angle of 20 degrees, so that it looks just like what we have from this end, so that we can see the perpendicular, the parallel, and the parallel. We can see it properly now. But now, according to this angle here, this is your adjacent this side according to this angle, because the angle is now at this point. So this becomes your adjacent, and anything that has to do with adjacent has got to do with cos. So this one is going to be using now the weight of the object, because this object, we are given the mass of the object. Remember, we are given the mass of 50 kgs here. If not mistaken, that's mass of what? Of 50 kgs there. All right. So from the mass of 50 kgs that we have there, what are we going to do with this mass? It is going to give us this, which is supposed to be mg, which is w here. So it's going to be w cos, because it's on the adjacent, so it's cos. So it's going to be w cos 20 degrees, the angle that we are given here, which is 20. But this w is mg. Remember that w is equivalent to mg. So it's going to be mass of 50 times g, which is 9,8 cos 20 degrees, like this. So this is what you're going to have on this part, which is actually going downwards. So you can just do it like this so that we can see this is the arrow shows that it's going downwards, and this is going this side like this. All right, and this is now opposite. As you can see, it's directly opposite to 20, and anything that has got opposite is supposed to use sine. So this is going to be w sine 20 degrees. All right, and w is mg, which is the mass, just like what we did here, mass 50 times 9.8 times sine 20 degrees. So this is the parallel part now that we have. So now let's see, because what we need is to find the friction force and the normal force. So where are we going to find the friction now? I want you to see what is happening. This is your friction. Obvious, the friction here is opposing these components which are in a parallel manner according to your diagram. Guys, you calculate friction according to your diagram. So according to this diagram, this friction is opposing these two forces. I mean, it's going this direction, and this, because we are talking about a parallel, those forces which are in parallel like this. So this force of the frictional force that we want to calculate, we are going to take it like this. Frictional is equivalent to, I want you to see, it's going to be the difference between these two, because these are the two that are in parallel. It's either this one of f cos 30 degrees, which is going to the right, which is a positive, or this one, which is going this direction, which is to the negative, because the arrow is pointing this direction, which is you're going to the negative, this direction, which is a negative. So we're talking about the ones which are in parallel. So as you can see, this one is a positive, this one is negative. So we're going to subtract f cos 30 degrees minus the other one, which is parallel, because this frictional force that we have, it's in a parallel manner. So that is why it is affected by these components which are in a parallel manner. But here, this parallel part is having cos, so take note. So it's going to be the difference there. So it's going to be f cos 30 degrees minus the one that is opposing, because this is going this direction and this is going this direction. So it's going to oppose, to subtract. So you subtract w sine 20, which is this part here that we wrote. So it's going to be minus 50 times 9,8 times sine 20. All right, so this is what you're going to have, guys, from this part here. I hope we are still together there. So in order for you to just work out this, just combine, so that cos 30 from your calculator, you're going to obtain 0.686 and so forth. But you can just round off, which is going to be 0.866f minus, you multiply these together, which is going to be 167,590. So this is what you're going to have there. So you just leave it like that. Okay, remember what we need is to substitute here on this formula here. This is where we need to substitute. So this one is already there, so we now need the normal reaction, which is the normal force, which is going to be taken, as we know, guys, from our free diagram here, free force diagram, that this is what you're going to have as N. So which means you're talking about the ones which are perpendicular, like the ones which are moving this direction. This is where we can obtain friction, because friction will be opposing. If there is a force that is on this side, friction is going to be on the other side like this. That is why you took the ones which are in a parallel manner like that, which are like vertical. But these ones, we need the ones which are horizontal so that our N can be achieved. So which means we are referring to these ones which are forming a vertical like this one. It's a vertical line, but it's perpendicular to the plane, because the plane is like, so when it reaches the plane, it's going to be perpendicular, but it's a vertical line, this one. So you're going to take this one. As you can see, it's going downwards. Also, this one is going downwards. So there's no effect. They are going in the same direction. You're just going to add them together. They are not opposing each other. This arrow is facing downwards. This one is also facing downwards. So just add them together, okay? So that was the first part. So we move on to the second part, which is our N, which is equal to, so like I said, just add these together because they are facing the same direction. So it's F sine 20. So it's F sine 30, not 20. This is 30 there. So we're going to have F sine 30 degrees plus, because we are moving in the same direction with this one. These ones, we're talking about these ones. Take note, they're in the same direction, So we've got 50 times 9,8 times cos 20 degrees, which is this part here, which is in the same direction. Okay, so these are vertical lines, but when they meet the plane, they are going to meet at perpendicular at 90 degrees. So these are like perpendicular, that is, you are referring to the horizontal and the vertical. But the way that you take now, guys, is from this part here, the normal force and the frictional. So you can just combine this, because what we need now is to use our calculators there. So just find a decimal here, sine 30, which is something like 0.5 F. Okay, guys, this is not 0.5 F, so we've got 0.5 F like this. Combine these together, you're going to have plus, just multiply those numbers. It's going to be something like 460,449. All right, so that's our N here. So our N is there, the frictional force is there. So let's take these guys to our formula here and try make something to work here from this formula that we wrote. So which means we're going to substitute. There's no way we have to substitute here, guys. Let's substitute frictional, the coefficient of friction we are given, if you still remember, we are given this as 0.4. That was coefficient of friction, which is 0.4. All right, so we are going to have 0.4, which is equal to the frictional force now. So we are now substituting, guys, the frictional force over the normal force. So these are the ones that you're going to substitute the frictional force here, which is 0.8. So take note, this is 0.4, guys, 0.4. So you're going to have 0.866 F minus, so you're substituting this part here, minus 167.5, okay, over 590 over, okay, you substitute this part here, which is your N, which gave you this value here. So remember what you want to calculate, guys. Always bear in mind that you want to calculate F. That is why you see your answer, it has got F, because you want to calculate that F. All right, so you formulated an equation now using the frictional force and the normal force. So now with this equation that we have formulated, how are we going to solve? This one is just like a fraction, so you can just cross multiply here. Okay, that's 0.4 times 5, so make sure that it multiplies everything. 0.4 times 5, okay, which is gonna give us something like 0.2 then. 0.2f. Okay, you multiply again 0.4, and this one, it multiplies everything, so it's plus. You're going to obtain 184, 1796, okay, which is equal to 1 multiplies this side. So as you can see, this side is going to remain as it is because you're multiplying by 1. There's no effect, so it's going to be having 0.866 f minus 167,590 there, or you can just write 59. So what am I going to do from this part? I want to calculate f. So here I've got f, here I've got f, so I'm going to transpose, take this to one side of the equation so that I can actually calculate the value of f. Okay, so this is what I'm going to do. I'm going to transpose this because this is the smaller value, so I'm going to transpose this to the right hand side so that it can be minus 0.2f. So it's gonna be 0.866 minus 0.2, which is going to give us 0.666f. So you subtract this. So also you're going to transpose this minus to this one on the left hand side. So it was a minus. The moment it crosses the equal sign, it's going to be a plus. So you add this number to this number because it's now a positive there. You're going to obtain something like 351,7696. This is what you're going to have, guys. So in order for you to find f, as you can see, you're multiplying, so there's no way you have to divide both sides by 0.666, which is gonna give you something like f, which is this decimal, and it's this decimal 1A25. This is 5A26, something like that. So you can just round off to 3 decimal places and see what you're going to have, which is 5. So this is this a 5, guys, or it's now a 3, guys? This is 528,1. 5 is going to change this into 3, so it's going to be 3 like this, which is actually in Newton. So that is that was the idea, guys, on this question, how you were supposed to answer this question. So as you can see, it's made of a play around, like what is happening here, where you need to use the required formula according to what you're given. Which formula are you going to use? How are you going to apply the formula? Because it's not about knowing the formula only, it's also about how do you apply that formula and how do you connect the dots, also using your mathematical skills there from whatever that you'll be having. So that's it, guys, on this question that we had. We shall meet again working on question papers from Memo African Motives till we meet again.